Hey everybody, and welcome back to another fun and exciting intermediate math class. In today's lesson, we're going to be on page 431. Page 431 talks about radicals. And, up to this point, maybe you haven't heard a lot about a radical. Maybe you don't even know what that is. So let's go ahead and jump into it and let's figure out what these are. So here in lesson 10.8, we find an introduction to kind of a brand new topic that maybe you kind of know a little bit about, but maybe you still have a lot of questions. So what is a radical and how do we kind of work with it? And what are some different things we can do with these radicals in math, in algebra, especially as we're coming up on algebra class. So what we want to do is we want to, first of all, kind of understand the pieces, the parts, and kind of like the what is a radical. This lesson is fairly long, so I'm going to take this lesson and divide it into two parts. So we'll do the first part in this lesson, and then I'm going to make another video on the second part of this lesson just to make sure that we understand it all. I'm going to take some time here. So the first thing that I want to talk to you about is taking the root of the number is the opposite of exponents. All right, so let's kind of set this up just a little bit. So what is the opposite of an addition sign in math? So if I say we add something, what is the opposite of adding? Well, it's subtracting, right? What is the opposite of multiplication in math? Well, it's dividing, okay? So we've been doing this for a while. We've been like trying to get something from one side of the equation to the other side of the equation. We have to do the opposite. So if it was multiply, we have to divide. If it was divide, we have to multiply, things like that. Well, when we're dealing with exponents and we're dealing with this kind of repeated multiplication of an exponent, so what I'm gonna do is I'm gonna write x to the squared power, or x to the 2. What is the opposite of x squared? Well, it would be the square root of x, okay? That is the opposite sign. Now, you might think, what do you mean the opposite? Well, what is happening in, let's kind of go down here and look at this. What is happening when we do the square of something? So if we say 2 squared, what's happening? Well, what's happening is 2 times 2, and that equals 4. The opposite of that is saying that the square root of 4, and that's what this is right here. That means square root of equals 2. I want you to see this. Look. So if we take our exponent, and it's the index, and then we take our answer, and we put it here under this radical sign, and then if you look here, we take the base of the exponent, and it's back to our new answer. All right, so all the elements are there. So if we take 2 cubed, what does that mean? 2 times 2 times 2, and that equals 8. In a root or a radical problem, we would take the answer, and it becomes this number here under the radical sign. We take our exponent, and it is our new number that goes outside here. And then we take our number, our base for the original problem, and it becomes our new answer. So it's one of those things where it is the opposite of. I could show you this with addition. So 4 plus 3 equals 7. So if I switch things around and switch the sign to the opposite, well, then everything still works out. So 7 minus 3 equals 4. I took the answer and I switched it here to the minuend. I ended up leaving the second number the same, and then it came back to the answer was what we started with. The same thing is going on down here. The same process is taking place here. It just looks a little different to you because you're not as familiar with exponents and with radicals. But we will be, because we're going to work on this a lot. So let me go back over. I kind of said some of the vocabulary words there, but I want to go back over this so you make sure that you know it. These are parts of the radical. The radical sign, this word here in purple, is the purple part. So it is the radical sign. It's what tells us that we have a radical, okay? The radical sign. The index is this number here in the yellow color. The index is the number that kind of goes outside of the radical sign. And then we have the radicand, and the radicand is the number that's inside of the radical sign. So make sure that you're familiar with those words, because you will hear me say those quite a bit. So just make sure that you know what each one of those different pieces of the radical are. Okay, let's continue to move on here. When you hear me say square root, what does that mean? Square root is when the index is a 2. Okay? Square root is when the index is a 2. A cube root is when the index is 3. Very important to understand those two things. And you might say, well, what is it when it's an index of 4? You just say to the 4th root, or to the 5th root, or to the root of 5, something like that. The same thing with exponents, right? So x squared, x cubed, and then once it gets to a 4, you just say x to the 4th. Same thing with radicals. We would say square root, cube root, and then 4th root. That's how that works, okay? There is something else down here that's very, very important, and that is the understood root. I put that in quotation marks. Is always 2 when there is no written index. So if I just write a root sign, and let's say I put a, 10x underneath here. Well, that root sign is a square root sign. Why is it a square root sign? Because the understood root, the one that we're like, oh yeah, that is always there. So we don't have to write the 2 right here. It's understood. We've done understood things before, right? So let's take some other examples. What is the understood exponent of x? Well, it's a 1, okay? What is the understood coefficient of x? Well, it is also 1, but you don't have to write either one of those. So a lot of people think that when we get to square root, if there's no index there, they think, oh, that index is 1. It is not 1, okay? So be very careful that the understood index is not 1. The understood index is actually 2. Very important when you're doing this. All right, let's move along to the next thing, and this will be the last thing in this lesson. So, fractional exponents are another way of writing radicals. So the exponent becomes the exponent's fractional numerator, and the index becomes the exponent's fractional denominator. Whoa, what did you just say? Okay, let's back it up and let's say it again. The fractional exponents are another way of writing radicals. So here's a radical right here. What I just said is that we can have a fractional exponent. So what does that mean? So if I take my base, if I take my radicand, okay, my x, I can take these other two numbers, the exponent and the index, and I can make a fractional exponent. So if you look here, the exponent becomes the exponent's fractional numerator. So in other words, this number right here becomes my numerator of my fractional exponent. And this number, the index, becomes the exponent's fractional denominator. So this would have a 5. So 3 over 5 would be the answer, and that's now an exponent. So it's x to the 3 over 5, or x to the 3/5. Okay? And this might be like, what? What's going on? Don't really worry about what's going on as much as learning these two things out here. The exponent becomes the numerator. The index becomes the denominator. It's that easy. It really is. So don't make it harder than it is. Okay, so let's do another one. All right, so now W is going to become our base. The radicand is the base, so W to the 4 over 9. W to the 4/9. Why? Because the exponent becomes the numerator and the index becomes the denominator. That's it. Again, don't make this harder than it needs to be. All right, here's an interesting one. So we have the square root of 5, and we want to turn that into a fractional exponent. So we take the number 5, that's our base. We take the exponent. You say there is none, so I'm not going to write one. Wrong. You say, but there's no index either, so I'm not going to write one. Wrong. Okay? There is an exponent. What's the exponent? The exponent, the understood exponent, is always 1. What's the index? The understood index is always 2. So we do have a fraction right here. So the exponent, okay, becomes the numerator, and the index becomes the denominator. So this would be 5 to the 1/2. Now this concept becomes very important in algebra once we kind of get into algebra just a little bit. So there's some practice problems there. I want you to work on those. There's lots more to this lesson that I'm not going to go over in this video just because I don't want it to be a 25-minute video. So you're going to see me kind of break this lesson into 2 parts. Practice the first parts that I gave you. So I told you how to identify the parts to a radical. I told you how to take a radical and turn it into a fractional exponent. So work on those things here in the practice problems. And then the next lesson, we will teach you more about how to solve radicals. Okay? That's all I've got for you in this lesson. Hope you have a good one. If you missed anything, slide it back, watch it again. We'll see you later. Bye-bye.